Every while loop needs a way to stop. Without one, it runs forever, locking up your program. The key is a simple 4-step pattern that controls exactly how many times the loop executes. Master this pattern and you'll never write an accidental infinite loop. The loop variable pattern has 4 parts. First, initialize a variable before the loop starts. Second, test that variable in the while condition. Third, use the variable inside the loop body. Fourth, change the variable each iteration so the condition eventually becomes false. These 4 steps, initialize, test, use, change, form the backbone of every well-behaved while loop. Skip the 4th step, changing the variable, and the condition never becomes false. The loop runs forever. That's an infinite loop, and you'll have to manually stop the program. Here's the pattern in code. We set n to 0 before the loop. The while condition checks whether n is less than 5. Inside the body, we do something with n, then set n to n plus 1. Each pass, n increases 0, 1, 2, 3, 4. When n reaches 5, the condition n less than 5 becomes false and the loop stops. 5 iterations total. Notice the structure matches our 4 steps. N is initialized outside the loop, tested in the condition, used in the body, and changed at the end of each iteration. Let's apply this pattern to compute factorial. Factorial of 4 means 4 times 3 times 2 times 1, which equals 24. We need 2 variables working together. The loop variable I steps through each number from 1 to 4. The variable factorial holds a running product. It accumulates the result by multiplying in each value of I as the loop progresses. We initialize x to 4, the number whose factorial we want. We set factorial to 1, not 0. Starting at 0 would make every multiplication produce 0. We set I to 1. The while condition checks whether I is less than or equal to x. Inside the body, factorial is set to factorial times I, and then I is set to I plus 1. Let's trace through this loop iteration by iteration. We start with I equal to 1 and the factorial equal to 1. Check the condition, 1 is less than or equal to 4, true. Multiply factorial by I, 1 times 1 equals 1. Factorial stays at 1. I increases to 2. Second iteration, check 2 is less than or equal to 4, true. Multiply factorial by I, 1 times 2 equals 2. Factorial is now 2. I increases to 3. Third iteration, check 3 is less than or equal to 4, true. Multiply factorial by I, 2 times 3 equals 6. Factorial is now 6. I increases to 4. Fourth iteration, check 4 is less than or equal to 4, true since 4 equals 4, less than or equal still holds. Multiply factorial by I, 6 times 4 equals 24. Factorial is now 24. I increases to 5. Final check, 5 is less than or equal to 4, false. The loop stops. The answer stored in factorial is 24. Exactly 4 times 3 times 2 times 1. The loop variable I controlled the iterations. The running product, factorial, accumulated the multiplication across all 4 passes, 2 variables, 2 distinct rows. A common mistake, forgetting to update the loop variable. If we remove the line where I increases by 1, I stays at 1 forever. The condition, 1 less than or equal to 4, never becomes false. The loop runs endlessly and the program appears to freeze. You must manually stop it, pressing Ctrl+C in the terminal. Always verify your loop makes progress toward making its condition false. Python provides shorthand for updating variables. Instead of writing I equals I plus 1, write I plus equals 1. The plus equals operator adds the right side to the current value of I and stores the result back. This works with any arithmetic operator. Fact times equals 2 means fact is set to fact times 2. Minus equals subtracts. Divide equals divides. These are purely shorthand. The behavior is identical to writing the full expression. Here's the factorial code rewritten with shorthand. Factorial times equals, I replaces factorial equals factorial times I. Cleaner code, same result. 3 essential points: the loop variable pattern, initialize before the loop, test in the condition, use in the body, change each iteration. A running product variable accumulates results across iterations. Initialize it to 1 for multiplication, never 0. Shorthand operators like plus equals and times equals simplify update statements without changing behavior. With these tools, you can build while loops that compute factorials, running sums, and more. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.